4.8 is complex numbers. This is the point where everything we've done up until this point has been real numbers. Okay? Today we introduce imaginary numbers. Okay, so, yesterday when we were solving problems and we got negative discriminant, what were we saying? We were saying there were no real solutions. Okay, there were no real solutions because we could not take the square root of a negative number. Imaginary numbers allow us to take the square root of a negative number. And so even though there were no real solutions, why you guys kind of kept questioning, I kept writing no real solutions or 2 real or 1 real, then the fact that there can still be imaginary solutions. And that's kind of the direction we're going today. Okay, so this all falls under the big umbrella of complex numbers. Complex numbers have what is called the imaginary unit as part of them. So imaginary unit, I, which looks just like a variable I, but it represents the imaginary number. Now, 2 basic ideas of complex numbers. There's 2 facts. I'm going to start with the second one. The first one, I is equal to the square root of -1. You know how we always say you can't take the square root of a negative number? Well, you can when you're allowed to work with imaginary numbers. And that's what we're doing here. And then the other piece is that I squared is going to equal -1. Think about it. If I is the square root of -1, what happens when you square a square root? The square and the square root cancel each other out and you get whatever's under the radical, yes? And so thus, I squared is equal to -1. So those are 2 pieces you're going to have to know to go through this lesson. From this idea, when we see something like the square root of -5, the important part in there is that there is a negative, right? That negative, and actually what you'll usually see me do is rewrite this as square root of -1 times square root of 5, because that's still equivalent, right? -1 times 5 is -5. So square root of -1 times square root of 5 is square root of -5. But what do we say about square root of -1? Square root of -1 is I. Now, square root of -1 by itself is I. And so this can be rewritten as I times the square root of 5. So lesson 4.8 is going through a whole bunch of different stuff involving I. Okay, just the basics of how to work with I. But then we'll also kind of go back and review some of the stuff we've done throughout chapter 4 and throw in the I's now. Yeah.
This may be kind of a silly question, but can I fit into rational numbers or irrational numbers? Or
No.
Just enough a little imaginary.
Because everything we've done, so when we talk about rational versus irrational numbers, those are the 2 categories that real numbers break into.
Yeah.
So real numbers are either rational or irrational. Imaginary is a whole separate set. So no connection there. Mm-hmm.
This may also be another question, but in your calculator, if you punch in a square root and then put -5, it's like a syntax error, you can't do it. But if you put the negative out front of the square root,
That's a whole different
it's
thing.
a whole different thing. Okay.
Yep. And you can do that one because that's just saying the negative of the square root. So if the negative's outside the square root, you can do that. Okay. And that will come up as we go through more stuff. Probably not until tomorrow, but. Okay, so first thing we're going to practice is just simplifying square roots using I. So as we look at example A here, it's square root of -18. The first thing you probably notice is that there is a negative. So I'm going to, when I see a negative, to help us understand this, I'm going to separate that negative into a -1. So it's a square root of -1. Yes and no. So it is times the square root of 18, but I was going to break that up a little bit more if I can. Does the square root of 18 simplify any farther?
No, I mean
62. Okay.
It was just upside down.
Why 9 and 2?
Because 9 can be taken the square root of.
Because 9 is a perfect square, right? Okay, so I'm going to rewrite this. There's already the square root of negative 1 there. And then 18 breaks into 9 times 2. And notice, does that still equal negative 18? 9 times 2 is 18 times negative 1. Okay, what is the square root of negative 1? I. What is the square root of 9?
Doesn't matter how we do it.
3. And what is the square root of 2? Square root of 2. If I rewrite this, common form is to put the I and 3 together as 3I. And so 3I times the square root of 2. Now, what did you mean? Does it matter how we write the I?
Like, can I just do like a little line and then a dot, or do I have to do like a backwards J thing?
I did backwards.
Okay, so to me, it's almost kind of like a script I or a cursive I that I do. It doesn't necessarily have to be that. You just want to make sure it doesn't blend in with your ones or anything, you know. So it does need to be a normal form is a lowercase I. I was trying to think if you're allowed to do an uppercase I or not. I don't know, honestly. Yeah. So it's normally a lowercase I. I just tend to write mine as kind of like a script or cursive, but
I'm just going to try to make it littler because that looks like a upside down.
that is the thing. You have to make sure you know that it's an I. Yes.
No, do you have to break up the square and 18? Is that something you need to do?
If they ask you to simplify it, yes.
What if they don't? What if they don't break up? Like,
If, hold that thought.
oh man, we're gonna find one. It's 7. It's 7. I know it's 7.
Okay. Example B. Square root of negative 12. First and foremost, what do you guys see? There's a negative. Square root of negative 1. Does 12 have a perfect square root?
Like, so you take the 4. Oh wait.
Why 4?
Because you divide 4 and
4 times 3 is 12, and 4 is a
Perfect square.
perfect square. Why am I not using 6 times 2?
Because 6 and 2 don't have, neither of them are perfect.
6 is not a perfect square, 2 is not a perfect square. Okay, so I've got a negative 1, a 4, and a 3. What is the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 3? Square root of 3. So if I put this together nice and neatly, 2I square root of 3. And I realize I'm kind of writing a lot of steps down right now. It's kind of the learning stage. If you feel like you can eliminate some of these steps, I get it. You don't necessarily have to write all these steps down. Square root of negative 25. Again, first and foremost, we see a negative. What about the square root of 25? It's a perfect square, isn't it?
Oh, it is. It's something. I wasn't even thinking about that.
Okay. So what is the square root of negative 1? I. What's the square root of 25? And I times 5? 5I.
Wow, Lexi. Look at you go. I forgot the number.
So I didn't break that one up because 25 was already a perfect square. D.
I'm confused on what we substitute this in place of. Like, when are we supposed to use imaginary numbers?
That's a good idea. When there's
When you,
negatives in there.
yeah, when you have a negative and a radical, and you're allowed to give imaginary solutions. Okay. There are times when we're working with radicals and we only want real solutions, and so then you'll still say the square root of a negative number is no solution.
Well, let's say
But yeah, I mean, right now in everything we're doing today, we want the I answers.
we're just
Okay.
saying, like, give real solutions or give imaginary answers.
Mm-hmm. Square root of negative 7. We see the negative, right? Square root of negative 1. What about 7? How does 7 break up?
Oh, it's going to be just like
Okay.
the negative 5.
The best you can do is square root of 7 times 1, but we're still with the 7 then, aren't we? So I'm just going to leave this as square root of 7. So square root of negative 1 is I. Square root of 7? Square root of 7. So I square root of 7.
So could it be just like the 5 thing? That one's my second.
Okay. You get in the hang of it when you see that negative under the radical, it represents an I, right?
Yeah.
Okay, moving along. The next part we're going to talk about is the graphing and absolute value part. But first of all, a complex number. When we talk about complex numbers, they are often written in the form A plus BI, where A is the real part and BI is the imaginary part. So when we talk about complex numbers, that's how we'll leave a lot of our answers today, is in that form of A plus BI. Now, in terms of graphing, just like the coordinate plane, there's a complex plane where numbers A plus BI are graphed. Notice what it says. A plus BI refers to the ordered pair A, comma, B. Difference is normally we graph on an XY. Now instead of XY, it's going to be a real and imaginary axis. And I'll label those when we get down there here in a moment. No, that would have to be we'd have to add a three-dimensional, a third variable. We're not going there. That's not algebra 2. Okay, the other thing we're doing in this section, the absolute value of a complex number. So remember, if it's just a regular real number, when we do absolute value, that just means you make it positive. It's a little bit different when you have the A plus BI form. We have a formula. So the absolute value of A plus BI, square root of A squared plus B squared. Absolute value still represents the distance. Normally it's the distance from 0. Here it's going to, since it's an ordered pair AB, it's the distance from the origin 0, 0. So, on example 2 down here, we're doing 2 things for each of these problems. We're going to graph it, and we're going to find the absolute value of it. So, first of all, negative 5 plus 3i. How is that going to be written as an ordered pair? Yeah. A plus bi is A, comma B. So negative 5 plus 3i is negative 5, comma 3. Typical ordered pair is just that it's AB instead of XY. So normally it's an x-axis. Now this is my real axis. Or you can think of it as your a-axis. It's normally a y-axis. Now it's an imaginary axis. Or you can call it your b. So in order to graph negative 5, 3, what do we do? Yeah, left 5 up 3. I'm labeling it negative 5 plus 3i. Nothing else, more for the benefit of someone who looks at my notes later and tries to figure out what's what. So that's the graphing. Okay, what about absolute value? Square root of a squared plus b squared. So we're going to be doing the square root of negative 5 squared plus 3 squared. Notice it's a and b, so you don't take that I. It's not 3i, it's just 3. You guys did well on that. So negative 5 squared is 25. 3 squared is 9. You're always going to be adding 2 positive numbers under that radical. 25 plus 9 is 34. What is the square root of 34? Okay. Some decimal. And it's not that you couldn't give the decimal answer, but I think for the most part they want the radical answer in this section. And mean, officially, square root of 34 would be 5 point something, almost 6. So, and that's 5 point something, almost 6. What that's saying is that point is almost 6 away from the origin. Okay. Questions on what we did there?
We have to graph the absolute value of it.
No. Just graphing the ordered pair. Okay, B. Thoughts on 6i?
6 negative 1.
Okay. So 6i, think of it as 0 plus 6i. Because there's no real part showing. So the real part is 0, imaginary part is 6i. And so if it's 0 plus 6i, what is that as an ordered pair? 0, 6. Where is 0, 6? Left to right, 0, up 6. So that's the 6i. Thoughts on the absolute value?
Well, it'd be
It's
0
squared plus 6 squared, so it's going to be 36. Square root of 36.
Could you do this absolute value without your formula?
Yeah.
Why do I say that?
This is 0.
How far is 6i from 0, 0? It's just 6 straight up, isn't it? Okay. So, now, could you use the formula? Yeah, and I'm going to put the formula in here just in case anyone questions it. Square root of a squared plus b squared. So square root of 0 squared plus 6 squared. 0 squared is 0. 6 squared is 36. 0 plus 36. Square root of 36, which is 6. Which is what we already said, but putting the work down. What about C? 5 minus I. Okay. 5 minus I is 5 negative 1, because there's a negative 1 coefficient on I. So 5 negative 1 means I'm going to go right 5, down 1. So that is 5 minus I. Absolute value? Square root of 5 squared plus negative 1 squared. Square root of 25 plus 1. Square root of 26 is square root of 26. A little bit above 5. 5 point something. Yes? You could if you had to, but in this situation, they don't necessarily require you to split them, I don't think. So far, none of them that we've had have actually been splittable, so. And D, negative 3 minus 2i. So let's pretty much review at this point. We've covered all the aspects we need. So this is going to be the ordered pair. Negative 3, negative 2, which means I go left 3, down 2. Did you get your absolute value? What'd you guys get? Square root of negative 3 squared plus negative 2 squared. So negative 3 squared is 9. Negative 2 squared is 4. 9 plus 4 is square root of 13. No. You were just graphing them on the same grid.
It made a square.
Ish. I think it's a little bit longer than
I'm going to go with quadrilateral is what it made.
It made a kind of
That's not exactly a square.
I'm not even going to try to stand.
Made a four-sided shape, thus a quadrilateral. Okay. Again, as I said, we're just doing anything and everything we can with complex numbers in this lesson. Okay? So the next thing we're going to focus on is adding and subtracting. How do I know that these are adding and subtracting problems? They have pluses and minuses, specifically in between the parentheses, right? I know it sounds silly, but you need to pay attention to those. Okay, these are not multiplication problems. These are addition and subtraction problems because there's pluses and minuses between my parentheses. Okay, so here, my first problem has a plus sign, so this is an addition problem. How do you think we're going to add these complex numbers? Okay, like terms. Okay, real parts with real parts, imaginary parts with imaginary parts. Okay, basic how we always add in algebra. So 4 is going to add with negative 4. And it's a plus sign in the middle. So 4 plus negative 4 is 0. Okay, imaginary portions. Negative 3i adds to positive 3i. Negative 3i plus 3i. 0. 0 plus 0? 0. Yep. Officially, we could write 0 plus 0i if we wanted to, but with 0, we don't normally do that. What changes up on B? Yeah. This is no longer an addition sign, it's a subtraction. So we have a subtraction problem. Now, a couple of different ways you can do this. Okay? You can take that subtraction sign and distribute it all the way through if you want. And that's one way to think about it. Or just as you put your like terms together, remember that it's minus. I don't know what's best for me to teach, honestly. You know, I could go either way with this.
If you were to distribute that word, then would you just still subtract them just after it's distributed?
Then you would just be putting like terms together.
Okay.
Yeah. So, like what I was going to teach here is that 5 goes with negative 2, and that's a minus. So that means we're going to be doing 5 minus negative 2. Does that make sense how I did that?
Yeah.
And 5 minus negative 2 is 7. Now put our imaginary pieces together. Imaginary, I have negative 3i minus 4i. What's negative 3i minus 4i? Negative 7i. And since it's a negative 7i, I'm going to write my answer as 7 minus 7i. If it had come out plus 7i, then I'd say 7 plus 7i. Because it came out negative, I wrote 7 minus 7i.
Wait, I'm confused. Why is it a minus 4i? Because this one signs are so important in the middle.
Okay. Now, if you went the distributing option instead, I'll write it down here. It would have been 5 minus 3i minus negative 2 here would have become plus 2, and then minus 4i. If you know, that's what it would look like with that negative sign distributed, and then you can put like terms together. 5 and plus 2 is 7, negative 3i and minus 4i is negative 7i. So if that makes you happier, go for that. And C.
Yeah, there's 3 of them.
Okay, so first of all, notice there's 3 of them. One of them is addition. The other is subtraction. Again, you can go through and rewrite this without parentheses if you want. We can also just look for like terms. So if I look for all my real parts, what's real?
7.
7 plus negative 3 And what's that last part?
Minus 3.
Minus 3. So there's my real pieces. 7 plus negative 3 is 4. 4 minus 3 is 1. Imaginary pieces. Negative 2i plus I minus negative 2i. So, negative 2i plus I, negative I, minus that negative is going to be plus I, plus 2i, I mean. So, negative I plus 2i. Should be plus 1i.
Take your positive 2i and your negative 2i, those cancel out, and then you have your 1i in the middle.
That's another way to look at it. Yep.
That's how I did mine.
And again, it just goes, there's no one way to do these things. It's whatever your brain sees easiest.
The worst thing is, I'm gonna do good on this in class, but then the second I get home, I'm gonna be like, how do I do this again?
Okay.
This isn't that hard. I thought it was going to be the last part of it. But we're only starting.
The next part, I will probably have to continue this tomorrow. But we'll see what we can get started. We'll see. Multiplying complex numbers? We will multiply tomorrow.
Fantastic Friday will be tomorrow morning at 7 a.m. Come for game devotion and donuts.